Hello everyone, welcome back to the channel. Today I'm excited to walk you through a detailed review and explanation of a modern reimagined Boeing 707 2026 edition, a hypothetical next-gen version of the classic Boeing 707. Think of it as a blend of nostalgia and futuristic upgrades. I'll take you through everything you need to know, from design and specs to performance, features, and what we might expect in terms of release and pricing. Let's start by setting the stage. The original Boeing 707 is a legendary jetliner, first flown in 1957 and introduced into commercial service in 1958, and produced until the late 1970s. In fact, commercial production ended around 1978. The 707 family was one of the first widely adopted commercial jetliners and helped usher in the jet age. It was a four-engine, narrow-body, swept-wing jet used for transcontinental and transatlantic flights. Now imagine Boeing wants to revive the 707 brand name with a 21st century flavor. That gives us a framework. The aircraft would retain the spirit of the 707 long-range, reliable, four engines, but updated with modern materials, engines, avionics, efficiency, and passenger comfort. First, the design. The exterior would likely preserve the classic silhouette, a slender fuselage, straight main wing with moderate sweep, four engines in pods, a T-tail or conventional tail. But the new 707 could use composite materials in the wing skins, carbon fiber in sections of the fuselage, and lighter structural components. Winglets or advanced wingtip devices would improve aerodynamics and reduce drag. The leading edges and flaps would be refined for improved low-speed performance compared to the old 707. The fuselage cross-section might be slightly wider than the original to allow more cabin width and comfort. Inside, the cabin layout would be modern, modular seats, larger windows, LED lighting, noise insulation, and possibly a dual-class layout, premium and economy. The flight deck would be fully digital, with glass cockpit displays, fly-by-wire controls or at least advanced control augmentation, integrated avionics, satellite comm links, and modern navigation systems. Now on to specifications and performance, based on plausible assumptions and extrapolation from the original 707 lineage plus modern tech. Because there is no real official 2026 707 spec, this is a reasoned projection. Let's assume the modern 707 2026 has a length of about 46 to 48 meters, wingspan around 44 to 46 meters, and tail height around 13 meters. The maximum takeoff weight MTOW might be in the vicinity of 160,000 to 180,000 kilograms, 350,000 to 400,000 pounds. Given improvements in materials and structure. The empty weight without fuel and payload might be around 70,000 to 85,000 kilograms. For engines, instead of old turbojets or early turbofans, you'd expect four high-bypass turbofan engines, each producing perhaps 25,000 to 30,000 lb-f thrust or more, giving a total thrust of 100,000 to 120,000 lb-f. That would allow for more efficient cruise and better fuel burn compared to legacy jets. In terms of performance, cruise speed might be in the ballpark of Mach 0.82 to 0.84, roughly 850 to 900 km/h, which is solid for a mid-long-range jet. The service ceiling might reach 35,000 to 40,000 feet. Range would be a strong selling point, perhaps 8,000 to 10,000 kilometers or around 4,300 to 5,400 nautical miles with typical passenger load. In favorable conditions, maximum range might even approach 11,000 kilometers or more. For takeoff and landing, runway requirements would be moderate, perhaps needing 2,500 to 3,000 meters, 8,000 to 10,000 feet at MTOW, but shorter distances when lightly loaded. In terms of payload capacity, you could expect between 200 to 250 passengers in a single class, or a split configuration, say 30 business, 180 economy, without too much compromise. Cargo capacity in lower holds could also be meaningful for airlines that want flexibility. Fuel efficiency would be a big advantage over older designs. Thanks to modern engine technology, composite structures, aerodynamic refinements, and systems optimizations, fuel burn per seat would likely be far lower than older jets, perhaps comparable to or slightly below some modern twin jets, depending on how aggressive Boeing wants to make it. What about horsepower in aviation? We don't usually talk of horsepower but thrust. But if converted, each engine's thrust might correspond to tens of thousands of shaft horsepower equivalent. The important measure is that total thrust must exceed drag and allow for climb. The thrust-to-weight ratio design might aim for 0.25 to 0.3 at takeoff, giving good climb performance. Now let's talk features and systems. The 2026 707 would likely include features such as fly-by-wire or hybrid flight control systems, advanced autopilot, auto-landing capability, full envelope protection, modern safety systems, predictive maintenance systems, and health monitoring. Redundant systems and a robust fault-tolerant architecture would be essential. The avionics suite would support modern satellite navigation, ADS-B, data link, weather radar, traffic collision avoidance, and possibly connectivity for passengers' Wi-Fi, in-flight entertainment, real-time data. In the cabin, you might see smart lighting, mood lighting, in-seat power, and USB/USB-C ports, maybe even wireless charging surfaces, larger overhead bins, quieter airflow design, improved HVAC and sound insulation to reduce cabin noise dramatically. Emergency systems, environmental control, oxygen systems, and safety gear would meet or exceed the latest standards. From a performance standpoint, we'd expect good climb rates, solid cruise efficiency, and a comfortable descent and landing behavior. Because it is four-engine, it would have redundancy and safety in transoceanic routes, which might make it appealing for certain routes where twin jets are constrained by ETOPS rules. The aircraft would likely incorporate wing load balancing, load alleviation systems, active flutter suppression, and drag reduction measures like laminar flow control or boundary layer control in some areas. Maintenance and life cycle costs would be key. Boeing would aim to reduce maintenance intervals, use modular components, predictive diagnostics, and easy replacement of modules. The design might emphasize lower life cycle cost, lower fuel burn, reduced wear and tear, longer service intervals, and simplified inspections. As for expected release date and pricing, since nothing official exists, here is a projection. Boeing might aim to roll out a prototype by around 2025 or 2026, with certification in 2028 to 2030. So a 2026 edition might mean the unveiling or concept stage in 2026. Commercial deliveries might begin 2029 to 2030. Price per unit would likely be expensive, perhaps in the range of $150 to 300 million or more, depending on configuration, optional packages, and scale of production. For performance trade-offs, the modern 707 would face stiff competition from efficient modern twin jets like Airbus A321XLR, Boeing 787, etc. In terms of fuel per seat, its niche would be flexibility, redundancy, and route flexibility over water or remote routes. The four engines add weight and drag, but modern design and materials can mitigate that. Also, airlines considering it might accept slightly higher fuel cost in exchange for route flexibility or brand appeal. In summary, this imagined Boeing 707 2026 is a fusion of heritage and innovation, retaining the classic quad-jet lineage but upgraded with modern aerodynamics, materials, engines, avionics, and passenger comforts. It would aim for a cruise around Mach 0.82 to 0.84, range up to 10,000 kilometers, around 200 plus passenger capacity, modern systems, and a unit price possibly exceeding $150 million. Its release would be speculative, unveiled in mid-2020s and certified by late 2020s. While this remains hypothetical, such a project would be ambitious and would need to compete against highly efficient twin jets and evolving market demands. Thank you for watching. If Boeing ever actually brings back the 707 name with a modern version, I hope this gives you a vision